AI agents that actually deliver. Today, guys, I'm going to share with you a very important technical innovation that was published by the AG2 team, formerly known as Autogen. It's kind of complex, but it's very important because it's a huge milestone in adjusting the agent's reasoning capabilities. Basically, one of the biggest upsides AI agents, AI in general, many people didn't adopt this technology yet, claim that it hallucinates and not reliable. And very often it is correct. And while I believe that as models will improve, the results and the output that is being generated by the agents is going to improve as well. But we already have many people innovating and adjusting the prompting and just the output generation process in order to yield better results. And this is what was created by the AG2 team. Let's cover, first of all, what is reasoning. So I created this diagram by using OpenAI. So we have different types of generating output. The most simple type is just giving the LLM an input, a prompt, and asking for an output generation. Then OpenAI provided us with the chain of thought. I mean, many researchers and different users provided us with the chain of thought, but OpenAI used this with O1, so it does the chain of thought under the hood. Basically, we provide the prompt, the input, and then under the hood we have a step-by-step reasoning process leading to a final conclusion. Now, a few weeks ago, AG2 team published a research paper and also a notebook about a new solution, which is basically a reasoning agent that has ability to do beam search. Let me show you what is a beam search. Basically, blog post. This is how it looks like. So you provide a prompt, an input, and then you have a few alternatives, a few routes. Then you have a grader agent that basically provides a grade to each one of the paths. So, for example, let's say we ask a question regarding which ice cream should I pick. So we have three alternatives: chocolate, vanilla, and banana. The grader is going to say which type of answers seems most promising. Let's say it chooses two alternatives. So it chose the chocolate and banana. Then we go another layer downwards. Another route is suggested. So let's say we have the first flavor. Now we need to decide whether we want which type of topping. So for the chocolate, we have two alternatives of topping. So one, I don't know, chocolate chips, and the other one is, I don't know, gummies. And then the grader is going to select from these alternatives and give a grade. And eventually, what we have one path of the best ice cream. So we have the best ice cream flavors, then the best toppings, and then we have the best type of cone. So cone or cup or whatever. So this is basically, let me see if there's a better visual representation of this. No better visual representation here, but I think they have somewhere else a better visual representation. But I hope you guess the idea. Let me maybe ask ChatGPT to generate a better. Can you generate? You generate a good example for 8th grade about the beam search. Let's see what it tries. Will probably be better than the. Okay, so the step-by-step process is as follow. First, let's say we want to choose a video, so a movie. So we have 3 different genres: action, comedy, and mystery. These are our beams, the small set of options you'll focus on. Instead of looking at every single genre, you only focus on these 3. Then we explore movies in each genre. So in action, we have Avengers, we have John Wick. In comedy, we have The Mask and Superbad. And in mystery, we have Sherlock Holmes and Knives Out. Again, then we are narrowing our focus, keeping only a few candidates from each genre. Then we look at 6 movies and rank them based on what sounds more exciting: Knives Out, John Wick, and Superbad. And eventually we pick one solution. So not necessarily better example, but this isn't the main focus of the video. If you want, you can check out my recent video, which did a deeper dive into the reasoning agent, the beam search. What I wanted to share with you today is, first of all, this was context, but I wanted to share with you a few more innovations that were promoted by the AG2 team. So basically what they're proposing is, beyond the beam search, we also have Monte Carlo tree search and also LATS, which is kind of similar to Monte Carlo, but I will share with you in a moment what is the difference. So they are saying, in previous posts, we introduced the reasoning agent which utilized beam search for systematic reasoning. Today, we include Monte Carlo tree search and language agent tree search. This is the code, not relevant. But what is relevant? First of all, you can provide ground truths in your prompts to achieve more precise evaluations, better grading. Another thing that is valuable is that you can provide a different model for the grading. So in my recent video, I mentioned that when you are grading, very often, if you are using the same model to grade the output, the grading might be kind of off. So it is a good practice to use a different grading model to grade the output. This also reminds me of the idea that was promoted by the AIDER team of having 2 different models for generating code. One is doing the strategy and the planning. Usually it's better to choose, for example, O1, and another model to do the execution of the code. And you can read about this in a blog post that was published by the AIDER team. Bottom line, also important. Separating code reasoning and editing. And as you can see here, the pair. So when you select, for example, O1 with itself, it's going to be, it produces 80%, almost 80% pass rate. But when you added O1 as an architect, the planner, and DeepSeek as the executioner, you had 85% pass rate. And these are more examples. So this is important, separating between the model that generates and does the thinking and the model that does the grading or the execution. Anyway, moving forward, so we have this alternative. Now, so we have the beam search, which I elaborated before. And now we also have the MCTs and the LATs. What are the MCTs? Let me close this. But I had this written down in a simplified way. So Monte Carlo. So imagine Monte Carlo like throwing dice multiple times to figure out the best pass. So picture you're trying to find your way. No, I don't want this example. I had a better example for choosing ice cream. Okay, so let's cover the beam search. So we compare apples to apples. Same analogy. So beam search is, you walk into an ice cream shop with 20 flavors. First, you quickly sample a set of most promising flavors, maybe 3 or 5 that sounds really good. Then you pick your 2 among these and sample different variations. So topping in cone versus cup. Finally, you choose the best combination from the small group. So the key idea, you don't check every flavor. Instead, you focus on a few good candidates each time and keep narrowing them down until only the best one remains. The pros is fast because you keep the best flavors at each step and it's easier for your taste buds. The cons, you might miss a surprising flavor that you never tried because you only started with a small group. So let's say you want to solve a bug. So you have three alternatives. And one alternative is uploading the bug to Stack Overflow. Another alternative is uploading the bug to ChatGPT, and the third alternative is sending the error log to the SaaS company in which your error occurred. So these are three alternatives. And then based on after like the grader is going to select two of these alternatives and then it's going to narrow down the alternatives and eventually it's going to select the best path. I know it might sound complex, but as soon as you start messing around with this, you will get a better idea. Now let's discuss the Monte Carlo tree search. The tree search, yes. So choosing an ice cream. So instead of picking just a few flavors at first, you try random scoops here and there. Each time you note whether you liked or disliked what you tried. After many tries, you figured out which combo you like the best. And the key idea is you simulate the experience of trying a flavor multiple times. And the more you try, the more data you gather. It's good for exploring different flavors, especially if you have no clue which ones are going to be good initially. And you can discover hidden gems because you test randomly many different, you just make a lot of tastings and testing. And the cons, you might end up testing a bunch of gross flavors before finding what you like, and it can be slower. So in a business use case, it can be more expensive because you're using a lot of tokens. Now, the language agent research is similar to the Monte Carlo, but after each taste, you take a quick break to reflect. So you kind of figure out whether or not you liked it. So maybe you say, I love crunchy toppings, but not fruity ones. So next time you sample, you skip the fruity flavors and focus only on crunchy options. Now let me show you. I hope this is might be a bit confusing, but it's very important to understand because for those of you who are building agents in production level and want them to be reliable, you must be able to decide which reasoning you're going to use. Obviously, it's a matter of trial and error, but it's very important to understand these alternatives. Let's go back to the blog post by the AG2 team because it might be explaining this better. So when to use each method. So use the beam search when you want a deterministic search process. You can reliably evaluate intermediate steps. You need fast and memory efficient search. The solution space is relatively small and structured, and early decisions strongly influence final outcomes. So, because in the beam search, this is constructed as a tree, and let's say we have the three alternatives that I mentioned before regarding bug fixes. Once you decide that one route is irrelevant, you are not going to test that route anymore. So early decisions really influence the outcome in this case. Because as you see here, let's say we have here checking the error in Stack Overflow. This is checking the error in ChatGPT, and this is checking the error by opening a ticket. If we decide not to check the next steps after checking the error in ChatGPT, we are completely eliminating this route, this alternative from our bug solving process. So this is important, and it can be a huge downside because we are just eliminating an alternative at the beginning of trying to solve the challenge. When to use Monte Carlos, so you need a stochastic exploration of solution path. Final outcome evaluation is more reliable than intermediate steps. So in this case, more relevant when we don't mind doing a lot of trial and error, but very important for us to get it right at the end. But we don't mind doing many errors in the meantime, trying to figure things out. So the solution space is large or complex. You want balanced exploration and exploitation. You have computational budget for multiple simulations. So this is very cost intensive. I'm going to use LATS, which is kind of similar to Monte Carlo, but it provides immediate reflection feedback before the next simulation. So it helps identify poor reasoning paths early for future improvement. And it's especially useful for complex multi-step reasoning. So it's kind of, I wouldn't say it's in the middle, but it's more like Monte Carlo, but with a twist of self-reflection and removing, eliminating completely irrelevant stuff in the way. So let's try to ask ChatGPT to give us another analogy just to nail this, because I kind of feel it was a bit messy, but the concept is very important. I'm not sure I completely understand the difference between all three alternatives. Please use another analogy, not the ice cream choosing. Explain to an 8th grade. Walk me through step by step, and also give me a business analogy for each one of the alternatives. Perhaps even give an explanation for a 6th grade. This should make things more clear. Okay. Let's break it down with a new analogy. Of finding a treasure. So beam search, how it works. You start by picking a few promising paths, maybe 3, that seem likely to lead to a treasure, like trails with shiny footprints, a map, or animal tracks. You follow those paths a little way and evaluate them. Do they seem to be going in the right direction? You drop any paths that look less promising and keep only the best ones. You repeat this process until you find the treasure. The key features is you focus only on the best looking path at every step, and you ignore the less promising trials early on, even if they might secretly lead to the treasure. Simplified for 6th grade, it's like picking only your top 3 trials and ignoring the rest. You explore those a little at a time and always pick the best from what you've seen. Now, Monte Carlo. How it works, assuming that we are on a treasure hunt, you randomly explore trials without knowing much at first. At each point, you simulate what might happen if you keep going down a certain path. After exploring several trails, you calculate which one seems most likely to lead to the treasure based on your results. You go back and do more simulations for that promising path, refining your choice. Key features: tries a bit of everything randomly before deciding which trial looks most promising. The more you simulate, the more confident you are about your final choice. Simplified for 6th grade, it's like randomly walking a bunch of trials to see which one feels the best. The more you try, the better your guess about where the treasure is. Now, the last one, language agent research, how it works. Like Monte Carlo's, you randomly explore trials and simulate outcomes, but before you continue exploring, you pause to reflect. What went well on this trial? What went wrong? You use the reflection to improve your choices for the next round, avoiding mistakes and focusing on better strategies. The key features is that you add a reflection step after exploring, and it helps you learn from each attempt, so you make smarter decisions in the next step, in the next round. Now, a business analogy, choosing the best ad campaign. So, not sure I want to read this because this video is already very long and messy. So, let's see this comparison. Might be good summary. So, beam search. So, treasure hunt analogy, follow the top 3 trials, refine step by step. The business example is test a few great ads repeatedly. The strengths are quick, efficient for small options. Weaknesses might miss surprising possibilities. Monte Carlo, we randomly explore trials until we find the best. The business use case is we test many ad ideas, we find the best ones. The strength is explore broadly, good for large spaces, and its weakness, it requires many simulations. And the last is randomly explore plus reflect after each round. So assuming we're in a business use case, we test as, learn from feedback each time. It combines exploration and learning, and the weakness is more complex and it requires thoughtful steps. I guess that's it for today, guys. I apologize for the video being a bit messy. I couldn't come up with better ideas how to explain this. Probably I'm going to do a follow-up video in which I put all of these alternatives, all of these reasoning paths into action, and then perhaps with a real use case, you will be able to understand this better. Anyway, if you have ideas how I could have explained this better or any criticism or feedback, leave them in the comment section below. While this might be complex, I think it's very important for people who are building agents. I also want to thank the AG2 team for innovating and bringing these ideas to us. I didn't think about this before reading the blog post, so this is a very interesting kind of in-between solution. Yeah, guess that's it for today, guys. Hope you enjoyed it. If you can like and subscribe, it would be awesome. Until next time, keep on automating.